Yes. It's Brady.
Caw.
And Levi.
Levi.
Do the bird noise.
Caw.
Caw.
Nerdish.
It's nerdish with a 3, not nerdish with an E. Why?
8 to 9:30 p.m. Tuesday, Wednesday, Thursday.
Yes, because nerdish with an E was taken.
And that's why we do it 8 to 9:30 p.m. Tuesday, Wednesday, Thursday.
Thank you for giving that reason for a question that I didn't ask.
That's sort of like the way we eliminate answers on the reading section.
Yeah, that's true. And I guess the other sections to a certain extent.
I think it's important when doing a rap to listen to the beat that's happening in your ear. Otherwise, you have a problem staying on beat.
Correct. We do the ACT and SAT, they're standardized tests to help you get into college.
We don't tutor rap. We shouldn't ever do that.
No, we're not pretending to be tutors of rap, even though we're really good. Sometimes you can be really good at something, but not be a good teacher. Case in point.
Point in case.
Point in case word.
Point in case something bad happens.
Like this?
Yes.
I think we're enriching your lives by you watching this.
I'm getting a phone call from a friend. Do you think I should pick it up now?
The phone call just was dropped. Maybe he'll leave you a voicemail.
Next time I'll pick it up during the stream. That way we can all talk to my friend Steve.
If you think this is not very high quality, don't worry. We're gonna do it again in 2 weeks.
Also, we're much better quality when we're teaching you all the things in a number tree.
Like prime factorization?
Yeah.
Oh, that's fun.
Yeah.
You break a number down into its prime parts until you can't break it down
We
anymore.
can probably do that right now.
Yeah, we're gonna
okay, so let's say 32.
I was gonna say 30. That's so close.
Oh my gosh.
All right, break it up.
Okay,
Any way you want. 2 and 16.
Okay, 2 and 16.
2 and 16. 16 is 4 and 4.
Okay, 4 and 4. Oh,
And
interesting.
each
So
4
16
is
a perfect
2,
square.
2. Yeah, exactly.
Okay, 2 and 2 and 2 and 2.
So it's 2 to the 5th.
Yeah, it's 2 to the 5th.
2 to the 5th, exactly.
Whoa.
Yes.
That's pretty cool.
You see that? It's that quick, now you know. Think about that for our whole show.
Now stop watching the stream because you've learned everything necessary.
Bum, 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 bum. We're in a box. You can help us by asking us questions in the hope that someday we can escape. Hello. Welcome. I'm Brady.
I'm Levi.
And together we're
Type on Glue. No? Wait.
No, it's Type on Glue.
Yeah.
But together we're nerdish. Someone say something?
No.
Press the button.
Press the button.
We'll press it again.
Okay. Well, what am I gonna do?
I don't know. Press the button.
Okay.
All right. Anyway.
Hey, so
Yeah.
does anybody
Does
have
anybody? I thought I was
Question.
gonna ask. Right. Go ahead. Sorry.
Do you think?
Hono Meru.
Oh no.
Hello.
What's up?
Welcome.
Hello. More like hello, Meru. Right?
Continue. We don't condone violence.
Should we write on the board with Burt's Bees chapstick?
No.
No?
That is a big fat no. Should we write on the board with these markers before I destroy them with my left-handed tendencies? Yes,
you are
we
a very
should.
left-handed tendon.
Yes, I
Man,
am.
You tutor you. Hey, Hono, do you have any questions? Anything you want to talk about or us to talk about? And you to watch?
Yeah. Wow, this thing was really high.
Yeah.
This is gonna be fun. This is one of my literal favorite lessons because once you get it, you feel really, really smart and accomplished.
You also look really smart, which is much more important. Optics are everything on the
Optics
SAT.
are literally everything. Can we go over like general geometry? Ooh.
Yeah.
Yeah, we can do that.
We can do that.
Yeah. So should
So
we do?
you want triangles? Are you into triangles? You want circles? Give us a shape.
I didn't realize how much I forgot and never understood.
I think we should start with triangles. Do you want to do polynomials first, and then we can do triangles, or you want to do triangles first?
I would say, let's start with triangles.
Yes. Okay.
Very good. Very good.
I like the way you tutor.
Thank you. Thank you. Thank you.
And I think the way you think.
Ah, that's kind of fun.
Yeah.
All right.
Very nice.
Sorry, Hono. Are you taking the SAT or the ACT? Sorry.
Sorry, Hono.
We're very sorry.
We should remember everything all the time, like Levi.
That didn't make sense.
I know. Doesn't mean I can't say it.
That's true.
Both, but the SAT is first. Well, that was
first.
good that button was there.
The SAT was the firstborn. Okay, so SAT gives you those formulas at the beginning of the math section. So you have the area of a triangle. You have the. Do you have perimeter of a triangle?
It's all the sides added up.
Yeah, you know that. They give you area of circles, perimeter of circles. What are they give you the 30, 60, 90 and the 45, 45, 90 triangles.
Yes.
So you have those ratios. If those ratios don't make sense to you,
ask us, tell us. We'll try to shed some light.
yeah. But don't ask us with words.
Ask us with your mind.
Or emojis. What are they called on here? Emotes?
Emoji words?
Emoji words?
Emote words.
Emote words.
Right. Very good, very good. All right.
What did you want to do?
Well, I wanted to show him some stuff. I don't know. A triangle area is 1/2 base times height. Start with that. I'm going to try to be more gentler. If I put in Discord these 4 questions I got wrong, can you go over them?
Yes,
absolutely.
we can. Yes, we can. Yes,
That's
we
the
can.
whole point.
That's what we want.
We want that.
Yes, we will pay you for those questions, but in answers.
Yeah, that's how we're going to pay you.
Yeah.
Yeah.
Our value system is questions and answers, not money.
With a little bit of interest. So the
Money's
answers
not.
will have a little bit of extra answer in them.
Right.
Yes.
They'll be extra interesting.
Ooh. Lever.
Lever to beaver?
I never called
or
you
something?
Lever before. Yo, dude, put your phone away. We're on stream.
I am getting the question from the Discord.
Yeah, go ahead, Honomero. Do they have the concepts that you're confused about? I'm guessing that they are. So maybe we just go over them and then continue with what we were going to talk about. Or if you want to go over general geometry, the problem is general geometry is huge.
General geometry.
That's your service.
Yes,
that's a new one.
Circumference.
Circumference and
General
general
geometry.
geometry. You got to put on a little costume for that.
Yes, what would that be? Maybe like a cheese hat? Like
military.
a triangular prism hat?
Yeah, I can see what you're saying.
Yeah, I don't think you can see it.
He put them.
You can probably hear it, mainly.
You got him?
Questions for stream.
Oh, this would be kind of fun.
I
You totally
put
put them. It's right there. It's in the bottom.
Well, I thought maybe they were... Oh, it's just 4 in a row.
You fool.
Got it. I am a fool.
It's okay, didn't know.
I pity.
Okay. Oh, this will be fun.
Oh, it's going to be so fun.
All right. Read what we got. Diameter is what?
Okay. The diameter of a bicycle wheel is 3 feet.
All right, hold on. Diameter of
This
wheel
is hard.
is 3 feet. Okay.
How far will it travel going 14 revolutions?
Okay. Oh, this is fun.
And they also say let pi equal 22 over 7.
Okay. How far will travel going 14
Going
revolutions?
14 revolutions.
Okay.
So that means this bike wheel that has a 3-foot diameter is traveling around the sun 14
Levi.
times.
Okay. Pi is 22 over 7. Okay. Fantastic. Great. I love problems like this.
I'm going to do the next one.
Okay, sounds
Okay,
good.
I'm going to erase this.
So, yeah, go ahead.
And I'm going to keep breathing. Is that okay?
What?
Yeah?
Breathing or reading?
Breathing.
Oh, do I want to keep breathing?
No, can I keep breathing? Is that also okay?
Oh, good question. I'm glad you asked. I'm going to say yes this time, but maybe not next time. Okay. We have a wheel. Diameter is 3 feet. So let's think about this for a sec. What about this circle do we think is important? Is it the circumference or is it the area? Well, it's going to be the circumference because the wheel is spinning on a level surface. It's not even spinning, it's rotating over a level surface. So the area of this wheel doesn't matter at all. It's all about the circumference of this, okay? So let's talk about that for a sec. Circumference is pi times diameter or 2 pi r.
Hono, does that make sense, that idea of the wheel turning, and that's why Brady cares about the circumference?
I'm gonna make it way more visual. I just wanted to say the area does not matter here for a sec. It's gonna make a lot more sense in like just a minute.
Should I keep on inserting myself?
Well, if I don't say something you think is important, by all means, do not ever say it. Don't
Right.
go over.
But like immediately once you start, because you haven't even given her the answer yet.
No.
I feel like that's not very good tutoring.
No, like how'd you even know how far it'll turn? Oh, we'll get there in a sec. Okay. Great question. Okay, but the problem is the area of this wheel is not important. It is the length around the outside that matters. Okay. Imagine this. We start with the bottom of the wheel touching the ground. Okay. I'm gonna say that this point on the wheel, if you imagine like a little piece of tape, it's probably gonna touch. So this thing is gonna be moving this way. So I'm gonna say it's gonna be moving this way. And it doesn't just slide that way, it rolls that way. So every little point on here is going to touch the ground at some point. Where's my yellow? Okay, that's going to touch it there. This is going to touch it, I don't know, what is that distance? Like probably right around here. All right, so this is going to touch there. Okay, is this making sense so far? As this thing rolls, these little pieces of the wheel will eventually make contact with the ground as this thing keeps going. Okay? Let me know if that makes sense. I mean, you've seen wheels turn before. They don't slide on the ground. Every part of the wheel, yeah, good, okay. Very good. All right, so let's just talk about one revolution here. All right, the circumference of this wheel is going to be pi times diameter, or 2 pi times the radius. We have the diameter though, so let's just use this one here. So it's going to be 3 times pi. So the circumference is going to be 3 pi. We'll use the 22/7 at the end. Right now we'll just keep it in terms of pi, okay? So that means that the length around this thing is 3 pi. And pi is around 3-ish, so this will be around 9 feet, okay? Every single point of this wheel will make contact with every single point on the ground. So one circumference of the wheel, which is an entire revolution, will be the same length of distance that it covers. All right, so let me use some different colors here. So like, I already used pink. Let's just say blue is like halfway. That's probably going to be right around here. And then we're going to put a fun little like triangle thing right here. That's probably going to be around here. And then let's end it with like a square thing here, and that's probably going to be around here. And then we get to the end of a revolution, okay? So this thing turns, all these shapes line up with where they hit, and this length here that the wheel will travel forward is equal to the circumference of the wheel because it makes contact with every single point along that line, okay? So the circumference is 3 pi, which means that one revolution is also going to be 3 pi feet.
Why not 3?
Get out of here. Because it's 3 pi. There's 3 pi's, okay? Let me know if you're still with me, okay? That's one revolution of the wheel. There are 14 revolutions. So it's going to be doing that 14 times, which means this length that it's going for one revolution, it's going to be doing that 14 times. So we're going to take 3 pi feet, which is, we're going to say per revolution. We're going to multiply it by 14 revolutions. It's going to be 3 times 14, which is 30, plus 12, which is 42. That's going to be 42 pi feet. Okay? That's how far this thing will travel forward. 42 pi feet. I don't have the answers in front of me, but the fact that they told us what to use for pi means we probably need to use that for pi. So 42 times pi, if pi is 3, which it's not, but it's close, that would be around 126, but it's going to be a little bit more than that. So we want to take, let's use a different color. We want to use 42 times 22 over 7. And, you know, there are some shortcuts here. So 42 over 1 times 22 over 7. Turns out we can do 42 over 7. That'll give us 6. Then we have 6 times 22, which is going to be 120 plus 12, 132. It's going to move forward 132 feet. Levi, is that one of the answers?
Yeah.
Is it?
I don't know.
Well,
I'm opening it. I'm opening it. It's opening.
I don't know what to do.
What's the answer?
I got 132.
Oh, yeah.
Is that the answer?
I don't know.
Well, you...
It's coming, it's coming, it's coming.
I don't know what to... I'm just so... What do I do?
You're going to scare Hono. Hono doesn't like it when you scare Hono.
Yeah, it's the right one. Okay, Hono's got it. Thanks, Hono. Levi is, you know, my business partner. Partner in crime. His crime being slow at finding the answer.
Yes, it is there.
Oh, thank you.
Yeah.
At least he, you know, came through. Do you want to do the second one?
Better late than never.
That's what Levi always says as soon as he shows up late.
Very cool.
I like this problem. I like this.
Yeah,
It's a fun one.
yeah. Quick.
All right, I'm going to clean this off. All right, Levi, come on up, huh?
Right.
Come on up. Oh, no.
No, sorry, I won't talk like that. You didn't like it last time.
I think Hono was the one that liked it the most.
Oh, that's right. So we have a rectangular prism. And what you drew, is that your work, Hono, on the page, the pencil, whatever? Is that you or is that somebody else? I know it's not you, but it's your writing. So the dimensions. Very good. Dimensions. You did it perfectly. So you set it up very well. Are 2x, 3x, and 4x. That means that we have this rectangular prism as you drew. And this is 2x, this is 3x, and this is 4x along that edge. So you got that right. And then I'm not sure what you did to get your answer. Maybe you just guessed. But the way to find the volume of, wait, did it say volume? I assume it did. No. Ah, that's what it is.
What is that asking for?
Surface area.
Oh, surface
There you
area.
go. Surface area. Okay. So for surface area, we need to think about all the, first of all, do you know what surface area is? Actually, I'll just explain it. It's all the surfaces. You probably knew that. If you didn't, now you know. It's just this face and that face and that face. So you have 6 surfaces. They're not all the same size. And you could feasibly just do every single face and find them all out. Or you could realize that opposite every face is an identical face. So this 2x3 face here, this side right here, is the same as this side right here, if that makes sense. So those two are going to be 2x times 3x. And let me know if you did this and possibly you just made an arithmetic error. But this is this side, but we're doing it twice. So we'll have this whole thing times 2. And then we also want this face. I don't know how well this stuff is going to show up. I'll just do the second face and we'll leave the third face blank. So now I'm going to do the top and the bottom faces. So the very top face is here, and the bottom face is here. And that'll be this 2 by this 4. So it'll be 2x times 4x. And we're going to have 2 of those as well. And then we have the last face, and I'll just do that in blue. That's going to be this front face here and the back face there. So that'll be 4 times 3, or 4x times 3x. So 4x times 3x, and we have 2 of those as well. Do you have any questions up until this point? Now we're just going to multiply through and then add them all together, and that'll be our surface area. To do that, we get that this guy is 2x times 3x is 6x squared times 2 is 12. So we have 12x squared for that one. Please let me know if anything I'm doing with this math is something you missed, because hopefully you can recognize where in this problem you went wrong. But your drawing was correct. And then for this guy, we have 2 times 2x, which is 4x. 4x times 4x is going to be 16x
Hey, it's
squared.
Mojo.
Mojo. Hey.
Mojo, 1, 2, 3.
Mojo, how about me? We. Anyway, what's up? Do you have questions? Ask questions. You're done, right? I think you're done. Congrats on the test again, by the way. And then this last one will be 2 times 4x, which is 8x, times 3x, which is 24x squared. 24x squared. To add these all together, what do we got? You are 100% done. Yeah, you are. Remember, thank you for keeping on stopping by, but once we get to the essays, check back in, because we do a lot of essay stuff on here too.
You got some pretty colors going on right now, man.
It's pretty
Very
pretty. Very pretty. Add these all together. 12, 16 is 28, plus 24 is 52. X squared. That should be the answer. I think that's the answer you put.
Yes,
I'm thinking of starting my own ACT tutoring thing for kids around my town. You should do it. Go for it.
Yeah, you should.
Yeah.
We agree with that, because that's what we did. Hono. Yeah, that's what you got, and it's got a what do you mean by the cross through it? Because like for number 7, what you put is also correct. I can't think of why that's not correct.
Yeah, maybe it's just you weren't sure of stuff.
I started circling. Hold on. Oh, okay. Want to talk about them though?
That's intelligent.
Okay,
Good
that is a
move.
good idea.
So do you have any questions on this one before Brady starts explaining his? Does this make sense, and do you know where you went wrong? Because it's important. Now, obviously, we can't know. It's nice when we tutor one-on-one because we can watch students go through the process, and then we see exactly what's wrong. So if you can identify what's wrong, then you won't make that mistake again. Cool. With these things, you want to use as many different color markers as possible. It makes it a little bit clearer for yourself. So make sure to do that next time.
Yes, when you're teaching on a clear pane of glass to lots of people online.
Yeah. Very good.
All right, the next one. You have a rectangular sheet of metal, and it is 9 feet by 20 feet. So when they tell you that, if there's not already a picture, draw a picture, definitely. You got 9 feet by 20. The question is, what is the radius of the largest circle that can be cut from this sheet? Okay. Well, let's just go through a bunch of circles and see what happens if they're larger and larger and larger, okay? We can't have a circle that's larger than this rectangle, otherwise we don't have the material to make it. We want to cut the circle out of this piece of metal or piece of paper, we'll see. So let's think. Is this the largest circle I can cut out of this?
Yes, my lord.
Oh my gosh. What planet are you from?
My lord!
Okay.
Why not 3?
Good night, Mojeword.
Have a good night, Mojo.
That's not going to do anything. Fantastic. Okay, this circle is clearly not the largest circle that we can cut out of this thing, so let's go a little bit bigger. Hey, look at that. Is that the biggest one? No, it's not. If you keep making it bigger, one of these dimensions is going to stop you before the other one does. All right? And it is the vertical dimension. When you get to this point, the circle can't be any bigger because of the vertical dimension. It can go wider, but we're not making an oval. We're making a circle, and it's going to be limited by that 9 right there. That is the largest circle you can draw. Okay? Which means the height of this thing, that's 9. We call that the diameter. If 9 is the diameter, the radius is going to be half of that, because the radius is always half of the diameter. The radius is going to be 4.5 feet, because that is the diameter divided by 2. Let me know if you need any more clarification on that. And then, do you want us to also talk about number 8? Because you said 4 problems, but you didn't circle 8.
Or cross off 8.
Or cross off 8.
Talk about it.
We can talk about 8 if you want. If you don't want to talk about 8, that's fine. We don't have to talk about 8. Okay, 8 too. You want to do this one?
Yes.
All right, sounds good.
Whoa, this is pretty.
I'll start you off with a triangle, Levi.
Oh, thank you.
F,
I do declare.
What do you declare?
I declare these goods that I'm
I was
bringing
going to say
across the
exactly. I was
border.
thinking that too. Declare these customs. That's very good. That's very
Are
good.
you drawing it for me?
Yep. It's like someone saying I declare bankruptcy. I declare bankruptcy!
Have I showed you the thing that Hercules actor did?
No.
So it was a Hercules actor who, he's clearly terrible, and he clearly doesn't know how to read a script. My teacher was so rude to me because he thought I wasn't trying hard enough. Wait, did you read that or no?
No.
That's dumb. We don't like that.
Yeah. You should tell your teacher that you are trying. It's just you need more clarification on things.
Yeah.
That's the job of the teacher.
Yes. Wait, this is 35. They're not the same, right?
You're right. They're not
Yeah.
the same. Oh wow, that could have been a disaster.
An enormous disaster.
Disaster. He hates me, I swear, because he thinks I don't need the course. Lol.
Is that because you're too, like, you know all the stuff, so you're just kind of coasting through?
He thinks I don't need the course. Huh. It's probably better if an adult doesn't hate a child that they're not the parent of. Because, like, as an adult, like, that's a child. So, like, a full-grown hatred for a child is probably not a good sign for a person to have. So maybe, hopefully he doesn't hate you. If he hates you, that he should get a different line of work. That doesn't sound like a healthy way to think about it. I don't know. I'm talking out of my,
Mouth,
who
mainly.
knows? Yeah.
Like, mainly out of your mouth.
My mouth word.
Mouth ward.
Yes.
Okay, we are trying to... I have no idea what the question is.
Levi.
Find x. Great. That is a very easy question to understand. We are finding the value of x. No, I'm positive he hates me because I cry too much. Oh.
That's not a reason.
That's valid.
Wait, no, it's not. No, it's not.
That's ridiculous.
That's not a reason. That should be a reason for him to come in and like ask you what's going on.
Yeah.
And see if everything's okay. Not to hate you.
Why don't you send him the link to Nerdish and we'll talk to him? I don't like the sound of him.
I don't like the sound of him. Oompa loompa loompa dee doo. Hey.
We don't like your teacher today.
Hey.
He doesn't like it.
We're always on your side.
Unconditional love.
Unconditional love.
love.
We only like getting one side of the story.
The one that matters.
Yes.
In this case. Okay, here. We got to find out x. A couple ways to do this. Are any sides of the triangle congruent to each other?
I hope not.
Dude. All right. Okay.
Nice.
We're trying to find x. I see a bunch of triangles here, so that's going to tip us off for some stuff, most likely. We'll see. It would be nice. So my first thought is that if we can find the this big angle here, so the 35 plus whatever that is, and then the 20 plus whatever that is, then we can add up to 180 and figure out x from there. But the issue is I don't think that's going to work. We don't know this angle and we don't know this angle. And there's no way to figure it out because it doesn't say that this line here bisects that bigger angle. It also doesn't say that these two sides are congruent, so it's not an isosceles triangle. We know that... Oh, that's cool, actually.
What's cool?
That's fun. Okay.
What's fun?
Would you? There are a couple of ways to do this. I'm going to do it possibly the easier way first. There are often a couple of ways to do this. But this is a hard problem. This not triangle thing here, so this shape, that shape is a quadrilateral. The interior angles of a quadrilateral add up to 108. The interior angles of a quadrilateral add up to 360 degrees. So if we know this angle, and this angle, then we can find x. And we do know what this angle is. It's going to be 360 minus 95, which will be 265. So this is 265 degrees here. So if that's 265, and that's 35, and that's 20, we have 360 equals 265 plus 30 plus 20 plus x. So x is our last piece. Now if we add them all together, bird.
Yes.
This goes over there. Oh, we get another 95, so that's nice. And then we subtract those two, we get minus 50. So it should be x equals 45 degrees.
I'd like that.
I think that's the answer.
I hope so.
Don't worry, I'm still...
Should I get another?
40. Where did I mess up? Oh, because that's 35. Sorry. Yeah. This should be a 35, so this is 40 degrees. That makes sense. 35 from there. Okay, there is also another way to do this problem. I did it using a quadrilateral. So this is one of those things, Hono, that maybe you've forgotten from geometry if you've forgotten the old basic stuff, which is the interior angles of a triangle add up to 180. The interior angles of a quadrilateral add up to 360. And the sum of the interior angles, this is the equation, sum of interior angles of a polygon, I'm not going to write that, equals the number of sides, n, minus 2 times 180. So that n is the number of sides. So if the number of sides is 3, you plug in 3, you get 3 minus 2 is 1 times 180 is 180. That makes sense, right? Because triangles, the interior angles add up to 180. Please stop me if you know this. Also, please stop me if you're no longer watching. Both of those things. Do them simultaneously. This is the sum that thing. I'm not going to write it. So let's say we have a quadrilateral. Same thing, plug it in, you get 4 minus 2, which is 2. 2 times 180 is 360. Essentially, as you add more sides to the polygon, you get another 180 degrees every single time. So let's, this follows, and let's say we have a 9-sided thing, which is a nonagon, Bird?
Yes.
Nonagon?
Yes.
Okay. Is that actually true, or are you just saying yes?
No, it is.
Okay. A nonagon, you plug in 9 minus 2 is 7. 7 times 180 is 700, and plus 560, which is 1260 degrees. So you can figure it out with that little formula there. Do you have any questions on this stuff? I can then, so that was the quadrilateral. Seems like you have no questions. I do hope you're still watching, Hono. Can you just say hi, just to confirm that? But I'm going to do one more way of doing this also. We are trying to find, let's use just the big triangle here. That's what we're going to do. It does look like you're here. You're watching. Very good. Just making sure. Thank you. We're going to do the big triangle now. So I redrew that. We know this is x. X. And we know that this whole thing here and this whole thing here, it'll be 180 minus those two will be x. So I think this is going to work because we're just adding these two up, right? They just have to be added together. So the equation we're making is 180, so the total number of degrees in this triangle, for the sum of the interior angles, will be x plus this angle and that angle, and this angle and that angle. So all of those angle measures together. So we have plus 20, plus 35, and then we still have to add in that little blue part and that little blue part, which is the rest of this little triangle, 180 minus 95. I hope that makes sense. So we're doing these two, and we don't actually know what each of them are, but we do know that we don't care because we're going to be adding them together anyway. So added together, they will be the difference of 95 and 180, which is 85. So we're going to add 85 here, and then we'll just do this equation and solve for x. And we get x equals 40. So, same answer, same start. The approach is different. It's about recognition. It's about throwing math at it. I saw triangles right away, so I said, okay, I'm going to try to do the sum of the interior angles being 180. But then I decided, well, I can't find those two angles, so I'm not going to use that. Maybe I'll use the quadrilateral. Then I did that these two angles added up to 360, so I found this one. And then I showed you the other way, which is sort of a bigger logical leap to kind of work through, but also works just as well. Do you have any questions on this, any follow-ups on any of these things, any of these concepts that we mentioned? Are you fully comfortable? If you're not fully comfortable, we will just hit those things real quick. Or real slow. Doesn't really matter. Whatever works best for you. Wow, no. Hey, Bird.
Yeah.
It's fine.
Huh?
That's what Hono said. 'Tis fine.
It's fine, huh? Heyo.
Hono, do you have any interest in hanging out while Brady talks about polynomials? Because graphing polynomials is something that people know how to do, and then when they get them on the test, they end up not knowing how to do them because they're, you learn at one point, and then the very, very small basic rules that you don't see again come up, and then nobody knows how to deal with it.
Correct.
Nobody. Not even Brady.
Not even me.
Not even Brady. Ooh. Interesting.
Check it out there.
Yeah.
Yeah?
Yeah.
Alright. Yeah, it'll be kind of fun.
It'll be kind of fun, I agree.
Yeah.
The only thing I have a problem with graphing and stuff is logs. You want to give Hono some challenge problems with graphing polynomials to see if she's telling the truth?
Or should I just talk about logs?
Give her the old stump word.
Graphing logs?
Give her something. Yeah. Well,
I mean, we have someone who specifically wants something talked about.
true. Totally true.
Yeah.
But I do think
In general.
that,
Yeah, I get
that this is more important, and I want to see if she actually knows this, if you can give her some, like,
Good idea.
something that looks a little strange.
And I'll see what she draws.
Yeah. You'll see what she draws.
Okay.
Explain it with words. What does the parabola look like?
Sometimes it's not even a parabola. Very good. All right.
But
Okay.
we can also definitely do logs.
Okay. So we're going to break this up.
Perfect. She's got
U-shape.
it. She's got it.
Very good. That's all it is. That's all you'll ever need.
I don't know why people
Okay.
have trouble with that.
Very good. All right. Here we go. We got two different starting blocks here. Polynomials are in the form, they look like this. Y equals a times x to the n plus b times x to the n minus 1 plus c times x to the n minus 2 dot 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 plus z or something like that. All right. They could be quadratic, so ax squared. They could be cubic, quartic, any degree you want. Okay. We're going to talk about end behavior first. Okay. So let's give you a very simple one here. If you just have y equals x, so y is equal to x. That is technically a polynomial. I guess it's more of a monomial, but the important thing here is that the highest degree, and degree, by the way, means exponent. Highest degree / exponent we have is just 1. We don't even see it, because it's just a 1. All right? X to the first. What that looks like, you should be very familiar with, is just this perfectly diagonal line at 45 degrees. Okay? Now notice it starts down here in the third quadrant and ends up in the first quadrant. Okay, interesting. The next odd exponent there is to talk about. Oh, I really should have color-coded these. Oh gosh. Oh, Levi, this is a disaster.
An enormous mistake.
Oh man, there's a great opportunity here. Okay, y is equal to x to the first. The next odd exponent is going to be x cubed. So y is equal to x cubed. And that's going to look like this. Whoa, look at that. Oh, this marker's not great. I got to push harder. It'll just ruin it. Okay, that's kind of what we got there. X cubed also starts in the third quadrant, ends up in the first quadrant. Okay, x to the fifth, x to the seventh. I think you can see what's going on here. Okay, the reason why they do this is because of what happens to negative numbers when you take them to exponents. Okay, the negative number taken to an odd exponent will stay negative. So think about like -2. If you take it to the first power, it just stays -2. This is not a good marker. All right. If you take it to the second power, it becomes +4. Very exciting. I'm gonna get this. This is not doing it for anyone, Levi. Literally no one. Yep. -2 to the third power is -8. Becomes negative again. Okay. So if we have an odd exponent and we have an x value that's negative, it's going to stay negative, and when it's positive, it'll stay positive, but it's not going to switch, okay? Which is why we get something like this. So x to the fifth looks a little bit like, geez, what does it look like? It's kind of crazy, but it's whatever. Now there's a lot of variations here. I'm just kind of giving you the main end behavior of these graphs, okay? Those are our odd exponents. Then we have when the leading term is taken to an even exponent. Okay. Gonna get rid of this. Whoa. There we go. Don't need that. I don't need it. I don't need it.
Bum, ba, bum, 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 bum.
Yes, it's the We Are Farmers commercial. It's definitely not a SpongeBob reference. Okay.
Really?
No, why not? I don't know. Even exponent. The first even exponent there is everyone's favorite. Y is equal to x squared. Looks like this. Now notice it matches itself across the y-axis. It's symmetrical across the y-axis. Because a negative number, when you square it, becomes positive. So everywhere we're going, everything's going to become positive. Okay? What about x to the fourth? Good question. I mean, I guess I'm saying that to myself, but Whatever.
It's a good question.
It's a very good question. I mean, a lot of people are wondering about it. Okay, y is equal to x to the fourth. It's basically just a tighter parabola. And again, there's all sorts of ways to adjust these and give them bumps and things like that. But just by itself, x to the fourth is, yeah. Okay, you see what's going on here, okay? Odd exponents do this. One of them's going down one way, the other one's going up the other way. Even exponents do this. All right, they both go up, okay? Now you can change that with a negative. The leading term, if you put a negative in front of them, so the coefficient becomes -1, they will flip like this. So, for instance, negative x cubed is going to look like this. All right? What was negative before has now become positive, and what's positive becomes negative. Oh, look at this. This fits right in my arm. There you go. Okay? With even exponents, they'll still point in the same direction, but that direction will now just be down. Okay? So if you get to the end of the graph, you're going to be going down here in the fourth quadrant and down here in the third quadrant if it's a negative leading coefficient. All right, so if we have negative x squared, that's going to be looking like this. Okay? And that's just the beginning. This is just end behavior. Tells you where to draw the tips of the arrows so you know what direction this polynomial is careening off in, what direction it's careening off in, you know, over there. Now we're going to talk about zeros, which are my favorite. Yes, they are. Yes, they are. Yes, they are.
Oh, gosh.
Okay.
You're going to scare a Hono.
No, I'm not going to scare Hono. Hono loves it.
Oh, no. Do you love it?
Do you say you love it, Hono? No.
Say it ain't so.
I will not go. Hono, yes. I don't like it when you talk like that. Please don't. All right, fine.
I like OML. Oh, my lord.
Is that what that means?
I assume.
Or maybe it's like on my laughter, please don't. You know, because they're laughing too hard. No, it's not that. There's no way it's that. Because it's not that.
Maybe it's Oh My Levi.
Oh My Levi. Oh My Lanta? That's
Oh My
something.
Lanta. Oh, it could be Oh My Lanta.
Probably Oh My Lanta.
What are you saying, Hono? It's a whole different language.
Bum bum ba da 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 dum bum 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 da da ba da bum bum ba da. Okay. Fun stuff. Fun stuff. Fun stuff. Zeros. We're getting to zeros time. Okay. Let's say we have a polynomial that looks like this. Y is equal to x plus 3 times x minus 2. Okay? Let's graph this thing. These right here are factors. And what the factors tell you are what the x-intercepts are. Okay? Now why is that? Well, if you're on the x-axis somewhere, your y value is 0. It's weird. It's the opposite of what you think. Because you think, oh, we're on the x-axis, it's x-intercept, x is 0. No, 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 no. You're somewhere on the x-axis, your y value is 0 to get you there. So if you put a 0 in for y and try to solve this thing, we're going to have 0 is equal to x plus 3 times x minus 2. Okay? And if you remember from algebra, whatever makes both of these separate factors 0 will make this solution, will make this equation work. So if we have x plus 3 over here, if we set that equal to 0, we're going to get x equals -3. If we set x minus 2 equal to 0, we're going to x equals 2. Okay? If x is either of these things, then one of these quantities will be 0. You multiply by that quantity, you're definitely going to get 0. So because of that, these are your x-intercepts. They're also called the solutions, also called the roots, also called the zeros. Okay? So we know for sure that this graph is going to be having an x-intercept at -3 and an x-intercept at +2. Okay? But what direction are we going? Well, if you think about the leading coefficient of this thing, we don't see it yet, but if you multiply this thing out, which you don't have to do, just think about the largest term you're going to get. You're going to have x times x, which is going to give you an x squared. Will you get a bigger exponent at all? No. That is the largest exponent you will get. You'll get some x times -2. You'll get an x to the first power, but that's not what defines the end behavior. It's the largest term that tells you what's going to happen to this thing. So this is going to mimic the graph of y equals x squared, which is even, so they both go the same sides. And our leading coefficient is going to be positive 1. Because here we have x times x, which is going to just give us positive 1x squared. So we're going to have things doing this. They're definitely going to be doing this, okay? So because of that, our end behavior is shooting off in that direction. They're both going up, and they're both going to the left and right. So it's going to be something like this. We could try to look closer at, where's it going to cross the y-axis. It really doesn't matter, though, okay? So that's what I mean by the factors turning into zeros. They tell you where you cross the x-intercept. However, there are 2 different kinds of zeros. There are zeros where you simply bounce, and then there's zeros where you break on through to the other side. Where are my Doors fans out there? Eh? Yeah, all that stuff. Okay? Here's the difference. We're going to say that this is x. This because it's positive, we're subtracting. Let's say that this is, I'm sorry, no, this is x minus 4. Let's say the factor created this is x minus 4, and then this right here is going to be x minus 9. The difference between them is that if you have a bouncing 0, then that factor needs to be taken to an even exponent. Okay? If the factor is not bouncing and it breaks through, it needs to be taken to an odd exponent, which is typically just 1, but it could be 3 or 5 or whatever. Okay? So an even 0, here we go, we're going to call them even and odd zeros. And it means the exponent that these are taken to. Even zeros, they bounce. Odd zeros break through. Levi, what time is it?
It's 9:05.
No, it's not.
Oh, 8:47.
Okay.
p.m.
Oh, thank you for PM. Exactly. Yeah. Okay. We're putting all the pieces together. Let's do a wild one. Y is equal to, oh no. Just let it go. It's fine. Okay. Y is equal to x plus 2 squared. X minus 3 cubed. Let's see what that is. All right. Yeah, that'll be fun.
Yeah, see?
Meh.
That's
Hold up our pants high and try to sell illegal liquor because it's the Prohibition era. Okay, the zeros here we can get from our factors. So we have x plus 2. The x value that makes that 0 is negative 2. So we're definitely here. Then we have x minus 3 cubed. The factor that, or the 0 that makes that true is x equals 3. So 1, 2, bam, x equals 3. Great. Let's think about what the leading coefficient is going to be. All right. Look at these separately. Here, you have x plus 2 squared. If you FOIL this all out, you're going to get an x squared at the beginning. All right? With this one, we have x minus 3 cubed. If you're going to have to like multiply it 3 different times, it's going to be kind of messy. Don't do it. But the largest thing you're going to get out of this is an x cubed. And we're multiplying these things together. So that when we multiply, you add the exponents, you get x to the 5th. So loosely, our graph is going to mimic x to the 5th. And x to the 5th is an odd, so it's either going to be doing this or this. And that is a positive coefficient. It's positive x to the 5th, so it's going to be doing this. We're starting down in the 3rd quadrant. We're going up into the 1st quadrant. Okay? So I'm just going to draw us some ending arrows doing this. The question is, do we break through the zeros or do we bounce? Let's start with this first one. So the negative 2 comes from this one. This is an even exponent. An even exponent means we're going to bounce. So we're going to approach this thing, briefly touch it, bounce. X minus 3 cubed, that's an odd exponent, which is going to break through. So we're going to break through, and we're going to go up to that right there. Oh, no. Oh, just hosted the stream for 3 viewers.
Who's this?
King Jason 576 just hosted the stream for 3 viewers.
King Jason, thank you.
Thank you, King
Dude,
Jason.
teach them very quickly.
Oh, man. Oh, what do you want to know, dude? Sorry. Is that right?
Sort of.
Okay.
But continue with this.
Okay, so let's do another one. And we're going to make it different. It's going to be fun. At least for those of us that think it's fun. What's 5 plus 5? Ha! I know that one. A window, right? Isn't that how it goes? Nah, man, it's, it's 2 hands. That's what it is. 2 human hands. Interesting. Our number system is base 10 because we have 10 fingers. It is the kind of logical number to pick to base our number system off of because we're so used to thinking in terms of 5s and 10s because of the way our hands are. Just kind of chew on that. King Jason, what's 6 minus 7? Think about that. We'll see if you really are the king. Okay. 2. That's correct. 6 minus 7 is 2. If you are at clown school, but you're at king school, Jason, yes. Yes, sure. Like, I believe that for a second. Okay, new message. What do we got? Okay. All right. We're going to do one more here, and then it's going to be Levi's turn. What do we got? We're going to have y is equal to negative 4 times x minus 6 squared times x plus 3 cubed times x minus 1 to the 4th. You look at this and you say, I got to eat dinner, have a good night. Yes, you do. You have a good night, Mr. King. I hope you eat like a king. Ha 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 ha. I didn't think it was funny either, Levi.
I liked it.
Did you?
Yeah. Well, no, I didn't. I like you, but I didn't like the joke at all.
That's a very good explanation of why you acted the way you did just now.
Yeah.
All right, let's put our zeros down first. We got one at positive 6. We're going to put that right there. We got one at negative 3. Put that one right there. We have one at positive 1. Excellent. Okay. What is our overall degree going to be? We got a degree of 2, degree of 3, degree of 4. So we add all those up, we're going to get 5 plus 4 is 9. This is going to be x to the 9th. But we have a negative in front of it, and it's a negative 4. So what we're going to have here is negative 4x to the 9th. The fact that it's 4 doesn't really matter that much, but the fact that it's negative is going to make a big difference. This is just eyeballing these graphs. We're not actually getting them accurate, so just calm down. You're getting really kind of sweaty.
Why not 3 below?
Okay, it's odd. It's an odd exponent. So that means we're doing this or we're doing this. You're definitely doing something like that. And it's negative. So we're not going up, we're going down. That's our end behavior. So we're doing some of this right here. Now's the fun part, bouncing or going straight through. First 0 we have is the x plus 3, 1, and that's cubic, so we're going to break through. Bam. Ah, geez. We broke through. Okay, next one, x minus 1 to the 4th. That's even, we're going to bounce. Bounce. You can see what's going to happen now. There's no way we could have to break through this and then go down. That's not possible, because if you break through and go down, you have to break through again. Not going to happen. It must be a bounce. Let's check. X minus 6 squared. It's even. It is going to be a bounce. And then we go down this way. All right? I have to go. Levi, you're up.
Yeah, you're done with these things?
Yeah.
What am I doing?
I thought you were going to do recognition or something. That's still okay.
No. I'm doing colons.
Colons. Colons are very good for you. If you don't have a colon, that's not good.
Yes.
That's what my doctor said. Dr. Colon. It's just my colon wearing a lab coat. The little diploma on the wall. It's fun. They made a cartoon show after him. Dr. Colon. Is that what you do? Let's do this.
Yeah. Tries it quicker.
You know
see
what
that, right?
You know what I don't condone?
No. Ow.
Violence.
Dang
I don't
it.
condone it. None of that. No violence.
Okay. So I'm going to go over some colons stuff. Does anybody know how to use colons on the SAT and ACT or how not to?
Are we
Actually,
talking?
tell me all the ways colons shouldn't be used.
Are we talking like automatic colons or manual colons?
We are talking left-handed colons.
Oh, jeez. They still make those?
Yes.
Huh.
They're... Okay. Does anybody have any burning questions about the grammar section of the SAT or ACT? They're basically the same thing.
Have fun.
Yeah, thanks, dude. Are you gonna have fun?
I hope so.
All right. I can do that. Colons. Don't need colons, good. Wait, don't colons need like their own complete phrase? Yeah. Okay, so terminology-wise, phrase I'm going to change to... Phrase is a phrase, it's just a bunch of words, or a certain number of words. Phrase has to have at least one word, that's what a phrase is. Actually, could a phrase only have one word, or does it have to have at least two words?
A phrase is a group of words.
A group of words. So a group of 0 words? Never mind, Brady. Brady made a face at me. Okay. So independent clause is, I think, what maybe you were saying. Maybe. So you have to have, and we're going to call this IC. That independent clause has the subject and verb. Yes, Hona? Subject and verb, and it's a complete thought. Sorry, that's bad. I don't like that at all. Let's leave that alone. Okay, for a colon, I'll do it here. You need that independent clause first. So you have to have a full, complete thought with the subject and verb before the colon. Then you put your colon, and then, well, that's kind of off-center. Colon, colon, and then whatever you want. Hona, have you watched the stream when I've gone over this at all, ever, before in the world? I'm going to come up with some examples. So people see these things for lists, so that's fine. You have to have that independent clause first, though. So if we say, I bought fruit, colon, apples, bananas, and pears. There you go. So this is fine. We have our independent clause here, so we're happy with that. And then this is whatever you want it to be. That's fine. So this is a list of things. It's not another independent clause. Like with a semicolon, you need the independent clauses on each side. Here, you need your independent clause first, and then this stuff. Now, if you took out the word fruit, and you say, I bought apples, bananas, and pears, then you can't have the colon. You should just say, I bought apples, bananas, and pears. You just go through it. Yes, this sets up this thing, but that's not the point. Because this by itself, I bought, doesn't work. You have to buy something. So we have to say fruit here, or whatever makes sense in context. So you say, I bought fruit. Now, in context, let's actually talk about that real quick. The independent clause sets up this whatever thing. So this second idea, you have two ideas. This must expand, explain, go deeper, something like that. It must expand on the first idea. So you wouldn't say, I go to school, colon, this pen is pink. Because those two things have clearly, this pen in pink does not explain me going to school. Now you also would not say, I would not say something like, I like Bob, colon, he likes me. The reason for that is that this does not explain this. I don't like Bob because he likes me. I like him and he likes me. They're not, this does not explain that. It doesn't go deeper. So I might put a semicolon here because we have two independent clauses, so we're happy with that. I would not use a colon in that case. Now, let's do another one here. If we say the jury returned its verdict. Colon. We can do this because we clearly have an independent clause here. The jury returned its verdict. Subject, verb, this is what it returned, whatever. And then we'll say guilty. This is fine because this clearly is the verdict. What's the verdict? It's a guilty verdict. So that it explains what the verdict was. It goes deeper, whatever it is. The jury returned its verdict, guilty. So again, independent clause here for this whole thing. And then you have your whatever. So this whatever refers to part of speech. It can be whatever part of speech you want it to be as long as it makes sense in context. The last one is when you have an independent clause at the end as well, which is also fine. So if we say, I love school, let's say I like school, I like school, it's where I get to learn. This is fine too. We have the independent clause first, right there. And then we have, something that goes deeper. I like school. Why do you like school? It's where I get to learn. Okay, so we're explaining the first idea with the second idea. We're setting it up with that colon. That's why you see things with lists. Now, this is also an independent clause here. That's fine. We can do whatever we want, part of speech-wise. Slayer Darth, what's up? You need to go to bed, most likely. It's going very well. It's going very, very well. So these are colons. These are one of the 4 ways to separate independent clauses. So that's why we use it when we do our separating independent clauses stuff, and we say colons are one of them. This is an example of separating 2 independent clauses. You could also use a period here. You could also use a semicolon here. You could also use a comma fanboys here. Any of those things. 1 a.m. 1 a.m. is not crazy, but it's kind of going to crazy town. Oh no, do you have any questions? Slayer Darth, do you have any questions? Colons. Before, just should do this, I guess. Those are colons. Independent clauses are absolutely necessary to understand colons. Awesome. Yeah, independent clauses are the most important part of the writing section on either test. This is not a good time to use a colon because this does not explain that. They don't necessarily ask you, okay, this, if used correctly, a semicolon or a colon, choose one. But sometimes they will give you a problem where you have to understand the context well enough to say, oh, I would use a colon here because the second idea explains the first idea. Okay, since they're... okay, you cover English. Oh yeah, sorry if that wasn't clear last time. Yeah, we do SAT and ACT. All of the SAT and ACT stuff, we do it. Right now our overlay is not working, so I couldn't do the science section particularly well if you want the ACT. But English stuff, yeah, I think this is pretty ideal if you want to ask some questions on that. Okay. You know what's going on right now? Brady is tutoring someone right now. Right now, Brady is with a student. They're both learning a great deal, bonding over their mutual love and respect of the SAT or ACT. Do American high school students gain certificates from their AP classes? Not exactly. So generally the way it works is whatever university they attend will decide to give credit based on them taking the AP class and then the AP tests. Yeah, so the SAT and ACT will give, your score report, and then you go to university, and then the university says, okay, well, we're not going to force you to take the intro math level class because you took calculus AB, AP, and you got a 4 on the exam, and a 4 is good enough for us to give you credit for that, so now you don't have to take that class to graduate our college. That's generally how it works. Okay, questions on English stuff. I did colons. Hono, if you are still hanging around, do you have any more math questions specifically that you know, other things, or do you want me to do more geometry stuff? I could talk, ooh, that's kind of fun. Yeah, I have a geometry idea. If you'd like to do that, let me know if you want to do my idea for geometry stuff. Or we could do more English-related things and stuff. I got new sandals. I have more questions I got wrong. Yes, let's do it. Let's do it. Let's do it. And Hono, are these questions that you're getting wrong, where are these questions coming from? It's from class, or is it from an SAT prep class course thing? Which is it? Is that my feet? I think my feet smell. I don't know if anybody else can smell that. Unlikely. Well, oh, got it, Hono. Not any math questions, SAT and ACT related. So yeah, we do, you know, we'll do general topics, but if you have questions, ask us your questions. You know, I'm not going to do calculus stuff or anything above that really, because it's not on the tests. But yeah, anything that will be on the tests, I am happy to teach those things. I will keep Discord open for you. Ahono just posted a question. Great. Very good, very good. Let's see what this is, and then we will do it. And circle the ones that are wrong. Great. Okay. Okay. Oh, number 3 is an interesting question. Slayer Darth, if you're at all interested in the question that Hono just asked, she asked it in the Discord. I don't know if you know what the Discord is, but you can do !Discord, go to the Discord link, look at the questions and questions for stream, and that's where the question is posted. But I'll rewrite some of it, so ignore that now. So we have, at what point does the number of non-prime numbers... Okay. At what point does number of non-primes after 1 exceed the number of primes? Did I spell exceed wrong? Like that? Whatever, you know the word, exceed. I should just read it here. No, I spelled it right, whatever. Exceed number of primes. Okay, so I'm not sure what the difficulty here was for you. So it wants non-primes and primes, so I'm just going to write out all the numbers. So 1, we don't care about, so let's just leave that. 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go to 11. Okay. Let's put this away. Oh, great. You have access to the Discord. Awesome. So let's say this is a prime, and 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 this is a prime. Okay. So I probably didn't write enough numbers. So let's say we have 1 prime, 2 primes, 3 primes, 4 primes, 5 primes. And then I will label the non-primes. Non, this is the first non-prime, this is the second non-prime, third, fourth, fifth. So the next non-prime, or the next number is 12, which is the next non-prime number, and that would put us at 6 non-primes. I don't know why I did that line. So that's where we end up. I forget exactly how the question was phrased. Probably at the number 12 is where it exceeds, because 12 is the 6th non-prime. Any questions on that, Hono? I'm not sure what the issue was for you, so I couldn't necessarily diagnose it. But I see in the way you went about it, you wrote out all the prime numbers. Are logs covered within the ACT maths? Yes, they are. Not anything super in-depth, but yes. It seems like you have no questions on this, Hono, so that's good. I will move on to the next one, unless you do have a question, and then let me know. Ooh, this is fun too. Okay, so a donut hole, so the hole in the middle of a donut, represents 15% of the volume of a donut. Oh, okay, so we're doing three-dimensional donut stuff. What is the volume of a 6-inch donut with a hole that is uniformly 2 inches thick? Okay, I'm going to assume that we're saying the donut is a perfect cylinder, because donuts are not perfect cylinders, but I guess for the purposes of this problem, we are assuming. Oh, you didn't know what this was asking. Yeah, so it was saying how many, you saw what I did. It's when does the number of non-prime numbers exceed the number of prime numbers? So you just have to label each one and count up how many non-primes and primes you have. Let me know if you're still confused. Okay, so a donut hole is, I don't want that, I want this. The donut hole is 15% of big V, we'll call, for the volume of the donut. And we want the volume of, so now we have a donut. So there's our donut. And there's the hole in it. Yeah? I hope that doesn't really look very good, but it's 2 inches high, so that's great. And then, oh, come on. Oh, come on. Okay, I don't know. It says a 6-inch donut. I'm going to assume, yes, you can post a link in the chat. I would prefer you post a link I would prefer you post a picture in the Discord in the questions for stream channel, just because I can't open up the links in the chat particularly easily from where I am right now. Okay, so I'm going to say that it's a 6-inch diameter. It may not be a 6-inch diameter because it just says a 6-inch donut. So let's say its diameter is 6 inches, not the radius. So the radius is 3. The radius is 3. It seems like you got that. And then we are saying, so we want the hole in it. So let's find the big V. And that's going to be, as you have, pi times 3 squared times the height, which is 2. So the volume without the hole, so there's no hole there, it's just a full donut, is going to be 18 pi cubic inches. Now, the donut hole is 15%, which means that we have to take away 15%. So there are a couple of ways you can do this. And this is an idea that I think we've talked about recently. If we're getting rid of 15%, so we're doing 18 minus 15% of 18. Right? We're taking away 15%. This is the same thing as doing 18 times 85%, right? 0.85 of 18. That's what we're actually left with donut-wise because there's no donut there. So whatever this is. Oh, wait, sorry, there's a pi. My bad. 18 pi. Did they tell you to round it? They said 3.14, yeah? So, It's going to take a long time to load. Oh no, great. Yeah, let's calculate some stuff. So we have 18 times 3.14, which is 56.52. Is that what you put, Hono? Thank you for putting that in Discord. I just saw it. I'll check it out in a sec. No. 56. Oh, yeah. 56.5, yeah. And then you got 48. So that's probably where you went wrong. But maybe not. No, you also got 48 there. Okay, so Hono, I got the same answer that you got. Yeah. So my guess is that we both misinterpreted the question, and when they say a 6-inch donut, they mean a donut with a radius of 6 inches? If you know that 48 is the wrong answer. But it seems like you took the perfect approach. I don't understand the question if it's not what we both did here. Yeah, I got no issue with what you did. Okay, post more questions if you'd like. I'm going to go on to Slayer Darth's question. Oh, you just posted. Okay, I got it. Ooh, this is fun. This is cool. Thanks for posting that. I'll take a look later. I definitely cannot look through the full thing now, but that's cool. Thank you, Slayer Darth. All right. Do either of you or anybody else, people on Facebook, people on YouTube, have any questions? Twitch is the easiest for us to answer, but you know, anybody got questions from anywhere, ideally related to what we do? Or you can ask questions about Brady. Or Hono, you can make a case for us never using those voices again, and I would gladly hear you out, although I probably will definitely use the voice again. All right. You demand that we don't. Okay, all right, I see. Got it. Cool. Explanation of variation problems. I actually don't know exactly what you mean by variation problems. Do you mean like permutations and combinations, and you know, if you have, you know, all the letters in the alphabet and you can have a license plate and how many ways to do that, that type of thing? They're just different terminology for different types of math across the pond. That song is very stuck in my head. Okay. Like when you have a direct relationship. Oh, got it. Yeah. Mm-hmm. Hey, both of you. Oh. Got it. Yeah. Sounds good. If you have any problems that you want to go over with that, but it seems like you got it, so we can do other stuff, or we can do that stuff if you want to solidify anything. We can do... Okay. I have a question on this one. What would be your approach to this problem? You know you have an 8:17 ratio, red to blue. How would you do this problem? Good. We're not lagging, are we? No, good. Okay. Ooh, that's fun. The light's in my eyes, but yes. Date?
No.
What are you doing?
The boy or comedy, the thing you're not going to.
Oh yeah, we're
All
black
right.
for a comedy show. Yeah,
Okay,
that's a
thanks.
good idea. Very grungy of you.
I appreciate it.
Very New York.
Oh gosh.
Wow, that's a lot of. By dividing, yeah. Oh no. So what? Dividing what? What by what? What by what? Or who? Whom by what? And which by who? There are a bunch of different ways to do it, for sure. We can set up, we know that if we have 8 red, we get 17 blue. You don't know. Okay, a couple ways to do this. We know, when you think ratio, this is a ratio, think proportion. So you start with a ratio, which is just a relationship, and then you can go to a proportion, which is basically the equation form of, yes, you can do a fraction. So that's where you're going. I actually don't want to say it now because I want to see if you can get there with the fraction on your own without me doing my explanation for it. Yeah, I'll give you a sec. I could have color-coded this, but there was no need. So yes, you can do a fraction. 8 over 17 equals 32 over x. Yes, perfect. Yes. 8, what? 8 over 17 equals 32 over x. Now, it could not be 8 over 17 equals x over 32, because then you don't have the correct relationships going across and down. So yeah, 8 to 17, that's the original ratio. 32 to what? Then you solve. So you can cross multiply, and you get 8x equals, whatever that is, divided by 8. So rather than do those things, I'll just get rid of this. This becomes 4. 4 times 17 is 40, 28, 68. So x equals 68. Good. That's awesome. So you said you didn't know, you figured it out. You could do it this way. You could also set up a different ratio, different proportion. You could say, so there's 8 of the original ratio over 32 equals 17 over x. And then you solve for x that way. It still ends up being the same thing, because if we cross multiply this, we get 8x equals 32 times 17. It does not matter. There are tons of ways to do this problem. There's another way where we could say, well, 8 to 17, that means that we have 8 times b equals 17 times r, where r and b are red and blue. And then we know that we have 32 red, so we do 8b equals 17 times 32, and then we solve for b. It's the same thing as these. We have 8x, whatever, 17, 32 on the other side. Lots of ways to do this. I think the proportion way is the most logical way, so I would recommend sticking with that one. Hono, real quick, or, Slayer Darth, anybody else. Side lengths of a triangle, is that possible? 1, 2, 3? Tell me why. Why not? Should maybe explain this a little bit better. Side lengths of a triangle? Question mark? Possible? Question mark? Let me know what you think. Are you allowed to have a triangle with those 3 side lengths? Is it feasible? No, not a right triangle necessarily. Any triangle. But I like what you're thinking. So if it's a right triangle, you could just do Pythagorean theorem and see if it works. But no, I'm talking about any triangle. Can you have a triangle with those 3 side lengths? This is getting at a basic concept that you may not have learned, but it's something very, very basic that was definitely early on in learning about triangles if you got taught it. So you probably forgot it because it's not a concept. It's not because of the special triangles. So it's not. It looks special because it's just 1, 2, 3, but it's actually not possible to have a triangle with these side lengths. And I'll explain that visually now. Okay, we are trying to draw this triangle. And let's say that we start with side length 3. So here's your start, here's your end of that side, and yeah? So that has a side length of 3. And now you want to connect this end and go 1 and then 2 to finish off this triangle. But you can't because you have to get 1 and 2 to get 3 across. So if you go up 2, it's not going to get quite far enough to here, right? We have 1, 2, but see how it's a little, we have this extra little bit of space here, and then coming back down, we're not going to get there again. That's going to be another one. See you, have fun. So if you think about it, if you flattened that as much as possible, you'd get really close to connecting those 2. But to actually get those ends to connect, you'd need this line to be on top of that 3 line because 1 and 2 add up to 3, right? So that's not good enough to make a triangle. You just end up making a line over top of itself. So the idea is you need to have the 2 smaller sides of the triangle add up to greater than the 3rd side. So we have, if we have side 1, side 2, and side 3 of a triangle. And we'll say that side 3 is the biggest side, so I'm going to write that as side 3 is greater than or equal to side 1, and it's also greater than or equal to side 2. So basically, side 3 is the biggest side or one of the biggest sides. Because if you have an equilateral triangle, all of these would be the same. But let's say that we have sides 1, 2, and 8. That's even clearer, right? We have a length of 8, and then we go 1 and 2. I mean, it's never going to get there. So what we've just learned is that the sum, so here's the thing you need to know. Side 1 plus side 2 has to be greater than side 3. It has to be. If they don't add up to bigger than side 3, the best they could do is equal it, but then you get this situation where you'd have to smush it down and just have a line. Does that idea make sense conceptually? It's not an idea that you use unless they'll ask you basically a straight up question about it. What are the possible side lengths of this triangle? Or a triangle, any triangle. You need the 2 smaller ones to add up to bigger than the last one. Which makes sense. If you have an equilateral triangle, you're fine. This can be 1, 1, and 1. Well, 1 plus 1 is certainly greater than 1, so you're fine there. And so it can work with anything. You just you see if the biggest side is too big for the other sides. It's not a super hard concept. I think it's kind of interesting. It's not something that you necessarily think about doing. But I forget what this is called. But it's the thing that does this. It makes sense. I hope. Seem to be no questions, at least. So that's good. So this will come up more often on the ACT, but it's not a concept that you always have to think about. It's only if they talk about side lengths of triangles only, and if they're possible or not, this is what it's asking about. This is the only thing it could be asking about. Now, side lengths of the triangle could be anything, but if they ask about if it's possible, here you go. Seems fine. Yeah, this is an old concept from very early geometry, most likely for you. And it's not one that's, super challenging. But it does trip people up. Okay, let's do, oh, wow, really? Okay. It's 9:30 now, so I'm out of time, but if anybody else has more questions, I'm happy to do maybe one now, or I can do them, oh wait, no, today's Thursday? Yeah, today's Thursday. Okay, I can do them next week, post them in the Discord, we'll answer them as we get to them. But it seems like everybody's pretty happy, maybe? Or at least doesn't have questions. So I will see you next week. We will be doing this again. But the best way to use our service is to do work on your own, figure out stuff you don't get, maybe try to learn it elsewhere, but then if you want a human being to explain it to you and it's on the SAT or ACT, then we will do that. Do you have time for one more? Yeah, probably. Depends on the question itself, but probably, yeah. What you got? Can you go over the 8 over 1732 problem again? Yeah, for sure. Okay. So we've established that we have an 8 to 17 ratio. And this is red to blue. And then we say that we actually have 32 red. So if we have 8 red for every 17 blue, or 17 blue for every 8 red, how many blue are we going to get if we have 32 red? Well, here, what we're going to do is we're going to set up a proportion. This is the best way to do it. If we have 8 red, we'll have 17 blue. It's creating relationships. So basically, we're saying that if you divide, it's saying if you just divide 8 by, the number of red by the number of blue, you will get a fraction equal to 8 over 17. That's the thought process. So we will set this equal to something else. We need the same exact ratio to happen no matter what, because we've been given that that's always going to be the ratio. So if we have 32 red, then how many blue are we going to get? Let's denote it as B. So we have B, and then you solve for B in this equation. So we can multiply both sides by B. These B's cancel. We get B times 8 over 17 equals 32. We could cross multiply. I don't know if cross multiplying is a thing that you do in Great Britain. I'm not sure if that's something you're taught in school. That's what a lot of American schools teach, is cross multiplying. When you have a fraction equals a fraction, you cross multiply. It's just getting rid of the denominator, so it's not anything special. So I'm not doing that here. I'm actually just multiplying by B first. And then to get rid of the 8/17, I'm going to multiply by 17 over 8. So that cancels, and we multiply by 17 over 8 on this side. And then B equals this. This can go to 4, so now we have B equals 4 times 17. So that means that B, the number of blue marbles, or whatever it is going to be 4 times 17, which is 68. Does that make sense? You want any more? Oh, wow. Okay, yeah, I mean, I don't know anything about the English system of education. Really nothing. You have to teach yourself linear algebra? Dang. That's a huge part of our curriculum. Enormous. So it's on the SAT for sure. Don't worry, I have to teach a lot of my students that stuff too, even though they've supposedly been taught it, but our school system is, poor at best sometimes. Yeah, it depends on the school. Yeah, that's what happens. Well, good on you for coming here, looking for other things and finding free stuff for yourself. It's good. We'll be back. Tuesday, Wednesday, Thursday next week. But for now, I'm going to go. Have a good Thursday, have a good Friday, and then have a good weekend. Friday's kind of part of the weekend. At least for me, because I don't tutor on Fridays, because I take Fridays and Saturdays off. Since you asked about my schedule. Okay, have a good night, everybody. I will see you next week. Good, I'm glad you understand. Come back with as many questions as you want, Slayer Darth and Hono and everybody else, and we will answer them as quickly and as efficiently and as functionally and happily and clearly as possible. Night.